Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I am going to give you a small trick regarding the identification of regular languages. So how to find out regular languages you are going to learn within this small video. Okay, so before that you can just see my profile. So this is about my brief profile, myself Murali Krishna Bokasamudram, and you can just have a look at my profile, and I'm going to teach you how to find out whether the given language is regular or not. So within this small video, you are able to learn about how to find out regular or non-regular. So usually, for example, if you take any language, okay, L, and usually the language which is infinite, it may be regular or may not be regular. The language which is finite, so it is always regular. For example, if L is a language, so L is equal to something like a power n, b power n, okay, and such that n is less than or equal to 10. So it is a finite. So maximum number of strings are from 0 to 10. There are 11 strings. Okay, and if it is infinite, for example, any language is infinite. So whether it is regular or not, you can identify based on the dependency. Okay, so first of all, first and foremost thing is every finite language is regular. So every finite is regular. Every finite, whatever is a finite, is a regular language only. Okay, it doesn't matter how many strings are there, even 1 crore or 2 crore strings, it is always regular. We can construct a machine with finite number of states. But if a language is infinite, whether it is regular or not, how to identify? There is a small trick here. For example, if L is equal to something like a power n, b power n, such that n is greater than or equal to 0. So how many strings are present here? Infinite strings. So we can have epsilon, we can have AB, AA, BB, and so on. Triple A followed by triple B, and so on. So A is followed by same number of B's. That means dependency is there. In an infinite language, if dependency is there, then it is not a regular language. For example, if no dependency, for instance, if I am taking language L is equal to something like a power I, b power j, such that I comma j greater than or equal to 0. So in this language, we are having a's followed by any number of b's. There is no restriction on the number of b's. Okay, there is no need of remembering the a's. Okay, but here there is a need of remembering the a's. In an infinite language, if dependency is there, it is not regular. Okay, that is one criteria. And even if you take a language like L is equal to something like a power I, b power j, and c power k. So all I, j, k are the independent. So there is no dependency. So even though it is infinite, it is regular. So a power I, b power j, c power k, 0 or more a's followed by 0 or more b's followed by 0 or more c's. So there is no dependency at all. After certain number of a's, b's may be any number followed by c's may be any number. So this is a regular language. But if you have a language like something like a power n, b power n, some c power k, such that n comma k greater than or equal to 0. Here there is a dependency. Okay, even though k is independent, but b's are dependent on a's, still this infinite language is not a regular language. Okay, and one more thing, if you computation is required, for example, L is equal to something like a power p, such that p is prime. That means to identify whether the given number is prime or not, some computation is required. So this is infinite language, this is not regular. If it is a finite, it is always regular. Whether it's a prime number or not, we can list out the prime numbers and we can construct a finite automata. But whereas here, a power p, p is a prime, is not a regular language because some computation is involved in it. Okay, so whether the computation is there in an infinite language or if dependency is there, then always it is the non-regular language. If it is infinite, if it is a finite, it doesn't matter what is the pattern of strings, it is always regular. Okay, every finite language is regular. It doesn't mean that all infinite are non-regular. There can be some infinite languages which are regular, but if it can be recognized by the finite automata, they can be recognized by finite automata only when there is no dependency in the infinite language, there is no computation, because finite automata cannot compute the things and finite automata cannot have a memory to remember the symbols when the dependency is there. So that's all about this trick to identify regular language. I hope everybody have understood this, and please do subscribe this session and subscribe the channel, and please do like it and press the bell button for getting notifications. Thank you so much. Thank you one and all. Have a nice day. Thank you.